So let's look at this reaction, which is the addition of a hydride is called actually reduction. So we'll look at the reaction scheme first, where we are going to start with the our carbonyl compound. We have the carbon double bond and the oxygen. Then we have the hydrogen. This is actually reducing of an aldehyde. This compound is an aldehyde. We are trying to reduce it and indeed see if the product we get is going to be a primary alcohol. So in step number 1, we are going to bring our lithium aluminium hydride. Okay, and then in step number 2, we are going to bring our acid, which is hydronium ion. Now, when predicting here, what we get is going to be our R in our carbon. So there we are going to have the OH on top, and then we're also going to have a hydrogen there and another hydrogen there. And this is actually a primary alcohol. So reducing an aldehyde gives a primary alcohol like that. Okay, we are going to go ahead and look at the reaction scheme, actually the reaction mechanism. Or before that, let's try to look at this example here. This is acetaldehyde, which we're having, which is the actual aldehyde, or ethanol if you want. You can actually call it ethanol, but the common name is actually acetaldehyde. So using the concept above, we are going to reduce it in 2 steps. So step number 1 will bring our lithium aluminium hydride like that, and then in step number 2 we'll bring our acid, and we expect to get acetal as a product, or ethanol actually. So CH3, and then we have on top there OH, and then we have the hydrogen there and another hydrogen down there. This is actually going to be acetal as a product. Sometimes you can call it ethanol. If you want to call it acid, you can actually call it ethanol. It's actually very easy to predict, but we'll go ahead and look at the reaction scheme of that particular reaction. Okay, so a reaction, actually mechanism, not scheme, sorry. Let's have a mechanism. So we are going to start with our carbonyl compound. The carbon and the oxygen have 2 lone pairs as usual. Then we're going to have our R group there. Now what happens is that we're going to, in step number 1, bring our hydride. So this is how we indicate a hydride. It's going to be a hydrogen, which is going to be H. Now this H will have a lone pair and a negative charge. That is a hydride. Then at the bottom, we indicate where we're getting this hydride from. So we're getting it from lithium aluminium hydride. That is how we actually indicate. Okay, now this hydride is going to use its lone pair to attack the carbon there, and then the pi bond is going to break, pushing the electrons towards the oxygen. And what we'll have is going to be R. We'll have a carbon at a single bond there. Now the oxygen will have now 3 lone pairs, a lone pair, a lone pair, and a lone pair. It will also have a negative charge. Now I'll bring my hydrogen, which was there already, down, and the one that attacks, I'm going to bring it there as a hydride. And then in step number 2, what I'm going to do is that I'm going to now bring my acid, which is hydronium ion. Now this oxygen, if you look at it, it is having a lone pair and it has excess electrons. So to use one of the lone pairs to abstract a proton from the acid. Remember, acids are proton donors. And then a bond there will break, we have water. So we have now R, we have the carbon. That is now going to become OH. Since the oxygen has picked a hydrogen, so it becomes OH. Then the hydrogen, which is going to be there, will maintain, and the one down will also maintain. Then we also have a water molecule as a byproduct, like that. But our main interest is the primary alcohol, which is going to be produced like that. So it's actually very easy. A reaction scheme very easy. Mechanism also very easy, and we are done like that.